Welcome, listeners, episode 19 of The Circuit. I am Ben Bajarin.
Greetings, Internet. I'm Jay Goldberg.
Next week, just a tease, we have a special guest. I won't tell you who, on a subject that has generated a lot of interest lately, so be prepared for that. I think will go very well. It'll be our first guest, which will be fun, and I actually think it'll go really well. So we are excited about that. So today, there's an interesting topic that's been circling around lately, and to be honest, everyone, I thought kind of the points that we are going to go down today was a already assumed consensus viewpoint, but apparently it's not, and that viewpoint is that there will be continued offloading of cloud AI to on-device processing. You know, when this first started 6, 7 months ago, it was all cloud. Most people are doing today, I would say 99% is still all cloud. And that's the most rich capabilities that exist, right? GPT, Bard, any service you've tried today. But it's interesting because there's a lot of good reasons that things might move on device, but it's not something that has really happened much today. And there's a lot of questions for that. So I know you have been in some of these conversations much as me, and so how do you think the narrative evolves, and then just overall viewpoint, right? That sure, it's not all going to be in the cloud, but a lot of it will be. But how does that narrative evolve? That on device will bring some advantage to these generative AI capabilities.
So I think everything's moving fast, and we're in early days. People looking at ChatGPT and they see it's very exciting, and everybody's dreaming big about it. Most people approach it through Dolly or ChatGPT, some through Stable Diffusion, but mostly they're interfacing with the cloud, and that's the assumption. There's all this talk about shortage of GPUs. We don't have enough H100s from NVIDIA. It's all talking about cloud data center based AI. But separate from that, what we're seeing in the actual community, the practitioners, the people who are building this, is there is a growing awareness of a desire to put this on devices, onto smartphones, onto PCs, onto smaller devices. Right? There was that leaked Google memo a few weeks ago, which laid out the case really clearly. The point of that piece was that the open source community is outpacing both Google and OpenAI in advancing AI capabilities. But if you actually dig into that a step further, what he's mostly talking about is on-device edge AI, shrinking down these massive models to the point where they can fit inside a compute footprint of a laptop, or people have ported it now to a Raspberry Pi. So I think a lot of the industry is still looking at this from the cloud point of view, but the people who are really doing it day to day have woken up very quickly to this reality, and we'll see how quickly the community gets there. I know just yesterday, with today's May 19th, just yesterday, OpenAI released an iOS app for ChatGPT. Now, that's still sending everything back to the cloud. Mm-hmm. I downloaded it, though, and I couldn't use it for 20 minutes because their servers were all full. Right? And so, nobody really knows what OpenAI's business model is. They don't seem to know. But I'm sure, at some point, when if they start becoming more serious about a business model, they're going to look at, hey, we're getting all this usage on devices. Is there a way we can make this simpler? Right? Yeah. Can we offload some of this calculation to the device and save? Yeah. You do that for 20% of your workloads, and you save a few $1 billion in capex. Those are big numbers pretty quickly.
Yeah. And I think that the two factors of this that come into play from conversations I've had is, one, it's just really expensive to keep doing all of this in the cloud. But the contrast to that was one of the things I thought was most interesting about this AI shift is a point that we've talked about, but that it's instantly available to any device with a smartphone or a PC if it's running in the cloud, right? So we don't have to wait for new hardware like we did with smartphones, or like we did with PCs, or like we would with this conceptual AR VR thing. Developers can't make money until those categories took off at any scale. However, today, if you run this in the cloud, anybody with a computer can access it. It's just really expensive to do so. So there's this paradox of massive TAM, massive development opportunity, but really, really expensive, versus if we were to tell the people, well, look, you need to wait until you have a device that's got 30 tops, trillions of operations per second across a number of cores. Well, there's a very small number of devices in the world that have that, right? So it's this striking balance that I think is super interesting. Again, acknowledging the economics of pure cloud, not sustainable, but also you kind of want to take advantage of cloud because it's got you the biggest TAM, versus wait 2 or 3 years before we have X number of 100 millions of units with enough compute to do this more on device.
Yeah, I mean, I think there are a few issues out there. There is a pretty serious technical limitation that is going to be a barrier for moving to the edge, and then there's a whole bunch of economic reasons, right? The technical reasons are, I mean, these models are big and they're growing, and so there's a sort of impetus. There's a perception you get better accuracy the bigger your model is. That's going to get tested. But already we're bumping up against the limits of compute that you can do on a device, or even in some cases in the cloud. Like, we're starting to bump up against some pretty serious memory limits, right? Dylan Patel had a very good article sort of walking through all of this. And then you try to bring some of these models to edge devices, like even the smaller models that are sort of built for running on the edge, like Stable Diffusion. There's not enough silicon compute power in the average laptop, in the average iPhone, or even an advanced iPhone. So there are some real technical limitations.
Yep.
I think, obviously those will improve a little bit as we get Moore's Law and next generation of devices come out. But I also think there's going to be we've already seen a lot of changes to the models themselves. Things like Llama, which are shrinking down models to much more manageable sizes. We're still not all the way there to get it really running well, but
right
on a device. But I'm pretty confident we'll get that part of it.
Yeah.
Right. But then
Agreed.
Separate from that, there are economic issues why you want to put everything on the device, right? Because, if you're like, there's a lot of interest in putting AI in video cameras for, surveillance, or unfortunately, right. But, those cameras cost $50. You can't put $200 of silicon in a $50 camera. So we have to sort of shrink that. And then you start talking about things like autonomy or even assisted driving, where you have to have chips in the car making decisions. You don't have time, even with the wonders of 5G and low latency. You need to make some pretty critical decisions in the car. You can't wait to go back and forth to the cloud.
Yep.
So there's still some things in the way, but economically, there's a very strong argument for pushing more and more to the cloud. I mean, more and more to the edge.
And I think you have a number of players, very, very powerful in semiconductors, who are advocates of this and want to see it happen. Qualcomm, one of them. There's been a number of articles that Qualcomm have come up, not just from their CEO, Cristiano Amon, but also a white paper. Apple seems to probably also be in this camp that they'll say, hey, look, we want to push on device, and we'll talk about some of those use cases in a little bit. Intel, AMD, I mean, anybody, right, at the edge, it benefits them to make this happen. But the question that I still struggle with, and this is the hardest part, I think, that, in my opinion, this transition will bring, is you could take a 10 billion parameter model, or let's just even say something to 15. The largest I have found is something like a 17 billion parameter model running on Apple Silicon, but Qualcomm's processors have done 7-8 billion parameter models. I've seen thing on x86 around 10 billion parameter models. Stable Diffusion, for an example, is around 800 million to a billion parameter model. My challenge is you try some of these things that happen, let's just say, purely on device, and they are not as good as the things that you do in cloud. And so I always have this view of, what do consumers expect? What is the expectation with the Surface? And anybody that's coming off of using GPT or Bard or any of these things has pretty high expectations, because you've tried it and you're like, man, this is really cool and it's pretty robust. And then you try something that's more localized and you see its limitations. It doesn't compare. And so that's sort of my initial concern is, let's say we run a X number parameter model and it can respond to emails for you, or it can do very light quick text message responses, and some of that might be okay, and I think some of those will be fully, but it's not going to write you an analysis or help with the market report or help with a 2,000 word article like most people are trying to do today. Those are just such large models. So it's the expectations gap is my point that I'm a little bit worried about in this 12, 18 month shift between cloud to some on device.
Well, I think we have time because I still stick by something I said a few episodes ago where we don't really know what AI is going to be used for. Right? There was a lot of excitement at first. Oh, it's going to be used for search. Now people are starting to rethink that. It's done really well in things like coding and providing suggestions for coding. But most of the developers I talk to say it still needs a lot of human intervention. Like it can spit out a lot of code,
Right.
but you still need someone who knows who knows how to read code to debug it and make sure it does what it's supposed to. 'Cause it still hallucinates and has errors. I know that with writing. Like I've tried to have it write blog posts for me, and I end up spending more time editing it than it would take me to just write it myself and edit it myself.
Right.
It's not. There's still a lot of right. We still don't know what it's going to be, what it's all going to be used for. So I think AI itself is way out of bounds in terms of the hype cycle. Like there are all these articles. I don't know if you've seen these. All these articles in the mainstream press about AI is going to solve all these major societal problems.
Right.
It's going to fix income inequality. It's going to fix the middle class.
Right.
No, what? How?
Yeah.
So we're kind of already we're headed towards disappointment no matter what. But that's fine. We'll go through the curve and we'll hit the valley of despair, and then we'll come out of it with a lot of interesting, useful things, which also gives us time to have the silicon catch up.
Yeah. No, agree. And there are two parts to the on-device thing that I do think is interesting. One that the Qualcomm, the both Cristiano and others have talked about that I think speaks to is accuracy, right? So that it has less chance to hallucinate, much more accurate in basically what you're asking from a prompt standpoint. And again, I'm not saying this is searching the web, but accuracy does matter, I think, in some of the things. And the other is privacy, and I really think that's a good point because you're seeing the news, right? Samsung used GPT and put their stuff up, and then it learned from it. Apple just had an announcement today that they're limiting use because they don't want that same thing to happen. They don't want Apple IP or knowledge going to the cloud and sitting there to be trained on. So there's always already a privacy angle that I think is important. But I'll just give this use case as an example because I think this is interesting, right? And this fits part of my overall thesis that wherever we're marching to, because you're right, we don't know what, the goal is that it helps us be more efficient or get things done more quickly. That's a part of our everyday workflows. And so my wife's a teacher, and as a part of their students' assessments, they have to do these things called progress on goals, which means that the teacher has to write a super long email to the parent giving them progress on goals. One of the teachers in her category has a 13-year-old son who helped her write her progress on goals using ChatGPT by just giving it a prompt and saying, here's the bullet points, here was the progress that was made, and it wrote this very nice, elaborate, colorfully worded email that actually came off like really good and ended up saving this teacher a lot of time. And as you know, teachers don't have a ton of time. So even things like that, right, I think is super interesting because it gets to a root and also say that's good on device, that can happen, and that should be private. There should be an element of privacy that is maintained on that. And I thought that was just a great use case for this point of like on device using Gen AI to help you write some emails as a primary use case that kind of fits these points we're saying, which is what can you do on device versus what can you do on cloud.
So I've had similar experiences with ChatGPT. The things I've found it useful for are similar types of writing. I don't want to get myself in trouble and talk about school applications, but part of the problem is a lot of the things that we're using it for, like that, are things that aren't necessarily going to be read that closely anyway.
Right.
Certainly, like the people I hear who are most excited about ChatGPT for authoring written work are the the people who send out lots of marketing emails, so
Right.
spam.
Right.
Right, so we're gonna meet a world really soon where we're gonna have ChatGPT writing things to be read by ChatGPT.
Yep, yep, yep. Well, and that's
Right,
already like a case.
but
I mean,
but
one of my biggest use cases is just summarizing an article I think is too long because I want to skim it anyway. Just give me the point. Give me the insight. But that poor person has spent a lot of time writing 1,000 words. I just want the paraphrased version.
right, so exactly, they're gonna use all they have to do is add brief to their keep it brief to their
Yep,
ChatGPT instructions for whatever they're writing next time.
yep,
I
yep.
had it summarize all of my blog posts. I had it read through all of my blog posts
Mm-hmm.
back to 10, 15 years, how long I've been doing it. And it said, Jay Goldberg is a believer in technology being used as a force for good,
Mm-hmm.
but recognizes that finance and capital matter. I was like, oh, okay. It also gave me a very high readability score, which
Very good.
I
Yeah.
can't quite tell if it's kissing my ass. So
I do the same
our
thing though.
robot
To be
friends are
honest,
here.
I do the same things to be honest though, just to see like, did it think I made the point I think I'm making? Like maybe I didn't do a good job. Like if it's walking away with the wrong
Yeah,
conclusion, then I didn't do a really good job. So I've used that
yeah,
as that part as well. Which again, so maybe there's elements of even just that, Jay, that could be done on device, right? That doesn't need to be a gigantic thing if it just takes your 1,000 words or whatever, 800 words, and then just says, hey, help you as an editor, right? Or help you rephrase things or give you those summaries. Like that probably can happen on device too.
yeah. I think that's the point. Is our threshold for accuracy is not 100%, right? We don't need
Right.
it to be. We don't want it to be, right? If we're going to write code for running nuclear power plants, ChatGPT is not the maybe is a starting point, but it's definitely not the end point. But for lots of other things, you don't need that. You don't need perfect accuracy. You need something fluffy
Right.
and good.
Right. And I really think the development part of this will be like super interesting, right? I use this app called Notion that is a kind of team collaborative project
Mm-hmm.
management type of thing. But you can also write, like articles in it. You can get into an article, use its little AI, and I know they've been experimenting with some form of let's put some of the, it's not there yet today, but some form of let's put some of this into the local app so that you've got offline capabilities. You don't have to be connected to benefit from some of these things, very simplistic things, even if it's just help me define a project, help me create a scope of work, help me outline the project goals for this, etc. Um, but ultimately that becomes a hybrid world, right? There's some of it on
Yeah,
device, and then there's some of it that goes back to cloud. And I think that might be the most economically favorable way. But for the developer, that's going to be a trade off to them, right? How much do they put on device, which will rely fully on its capabilities, hence the need for more compute at the edge. But they will balance those two things in terms of how much they leverage to the cloud versus that they're going to pay, and then how much they put onto the device. Because like I think we've talked about this before, Jasper, which I have tried, and it's okay, but that's like an $80 a month service, all on the cloud, right? Notion is a $10 a month service. Yes, the cloud, but I just don't think you can't charge people $80. And if the answer is I'm going to run it in the cloud and you're going to pay $100 a month, that's too much, right? So there needs to be an economic model that works for consumers too, because these things will not be free.
yeah, I agree, and I think ultimately what it's going to come down to is the economics of compute are going to encourage developers very strongly to move as much as possible to the edge, right? And in a lot of cases, that will be possible because of what I was just saying before about accuracy. Like we don't need 100% accuracy for a lot of these things, and so yes, moving to the device from the cloud will lower your accuracy or lower however you want to measure that, but that's okay because the things we're using it for don't need 100% accuracy.
Mm-hmm. Mm-hmm.
80% is fine, and so people will be willing to pay that penalty. And I think, and yeah, and then you factor in privacy on top of that. It definitely does make me nervous that I can see all the things I've ever asked ChatGPT to do. right? I mean, there's that whole list, and if I can see it, so can
Yeah. Yeah.
everybody else.
Right.
Uh, and so I think that's going to be important. And I'll say, like, sort of just going back to Qualcomm, one of the things that's really interesting to me, they announced a whole bunch of AI stuff this week, and when we've talked to them about it, it really sort of shifted my focus because up until recently, I've really been thinking about semiconductors for AI as being a data center problem, which means you need to have silicon that's running 100% of the time and needs to be super, super optimized for raw output. And that's a very clear, data center challenge. But when you're talking about getting a device to run on getting an AI device to run on the edge, that's not you're not optimizing for
Right.
100% performance. It's not going to be used, 5% of the time is still a lot. You're optimizing for power and speed.
Yep.
And so that opens up a whole that trade-off opens up a lot of you're going to have to that opens up a lot of avenues of improvement. And
Yep.
so I think that's a really important sort of shifting the focus. And I think that was a good
Yes.
point that came out of what they're working on.
Yes. And the other thing I'm intrigued by is the nature that this kind of on-device demand, the insatiable demand for compute that generative AI and all its future evolutions will drive, how that will change the way that the SoC or CPU GPU architects think about their cores going forward. And a good example of this is, when you look at sort of the two companies that have what we'll just call very capable AI units. So you could call this an NPU. Some people call it other things, but let's just say it's something that's doing that AI specific acceleration. So Qualcomm and Apple. Um, Both of those are kind of unique approaches, and we list these things in terms of tops. But at the same time, I've recently come to the conclusion that not all tops is created equal. So if somebody tells you that their CPU can do, I'm just making this up, but can do eight tops, right? So 8 trillion operations per second. I don't think that's equal to an equivalent 8 tops on an NPU, right? For example. And I recognize that workflow diversification across those cores is important, but tops per inference per watt, which is actually a super clever metric that Qualcomm is using, and I do think there's a lot of legs to that, is a factor, like you just said, low power, but also speed. And so I say all that to say I'm intrigued the way that this demand for on-device AI actually now informs semiconductor designers going forward for their SoCs, realizing again that not all tops are created equal. How might they make those trade-offs, right, in terms of their transistor budget, and try to make this more efficient and more capable over the next few years in their designs?
Yeah, I 100% agree because I mean I've been in these conversations. Nobody uses tops or flops as a useful metric, right? I've been in conversations where somebody's trying to sell a chip to a hyperscaler, and like you have your tops numbers on the first page, and then you never talk about them again. You just sort of that's the qualifying, like this is the realm in which we're in.
Right.
The real work, the real purchase decision is based around I'm a customer, I'm going to run my workloads on the silicon. What is the actual output there, and what does that cost me in terms of power and number of chips
Yeah.
I need to buy,
Yeah.
right? And the tops does not really factor into that conversation.
Yeah. I'm wondering too, and I don't think either of us have an answer. I'm just lobbing this out there in the off chance that someone more technical listens to our podcast and wants to chime in. I'm curious how metrics change to how do I say this, to quantify performance gains in generative AI on device, right? And so the things you use today is, you can use GPT or Bard, like you said, if you even get access to it, like the problem that you had, and you could see it go anywhere from 10 words a second to 30 words a second, right, depending on latency and or capabilities. Some of these things I tried on device that I think are interesting is you could get like 600 words instantaneously when it's running on device. So speed is there. But point being, I wonder if there's over the next couple of years, I don't think this is a 5-year thing, but over the next couple of years, like, are there ways that we can measure on device generative AI capabilities are getting better, are getting faster, or are getting more power efficient, right? Something like that.
Yeah, it's tricky because raw speeds and feeds aren't going to do it. You can't just give them tops, and accuracy is very, very, very hard to
Right.
define, let alone measure.
Right.
Right. I think a lot of those decisions are going to be made by people very, very close to the metal, doing very detailed power performance models. Right. Just this week, how many metrics have we seen? Like a dozen different metrics we've seen people use to demonstrate their performance.
Mm-hmm.
Inference
Mm-hmm.
per watt, queries per second per watt per dollar.
Mm-hmm.
Right. There's just, there's lots of metrics that people are going to use. And I don't know what's going to become the sort of leading flagship metric that people are going to use for the marketing. But I think the real work will be done very, very low level as people make these sort of very small calculations.
Right. Yeah, because I just don't think it's going to be as simple as we can run a 30 billion parameter model and it takes milliseconds or whatever. I just don't. That seems too simplistic. I also feel like there will be a observable performance gains. Like you'll have tried it before and you'll see that it's faster or more capable. Like there's some experiential parts of that, especially as the use cases grow. Right, that it can do a whole lot more than it will in the next 12 to 18 months.
Yeah.
And I say all of that because from what I know is coming in the second half, you will hear a lot of people start to demonstrate and show on-device generative AI things.
Yeah. I know in the literature, in the academic literature about this, there's a growing number of questions about how important is just the size of the model. Like we sort of in a new thing like this, it sort of seems the natural inclination is just make the model bigger and bigger and bigger. But I think there's an assumption that at some point we'll hit a point of declining returns.
Right.
So that's one factor that's out there. And then I think, you start looking for how do you measure performance? And I think I had this conversation with somebody this week where it's like, how do we think about it? And I think one of the metric I've been using is to the degree of human intervention required. Like I mentioned that before when I was talking about writing and coding, how much human intervention is going to be used. And I think autonomous vehicles are the perfect example of that because that's the metric that seems to get most scrutiny right now is human intervention per 100,000 miles or whatever. Right? That's a metric that people have used to talk about all these different autonomy systems. And I think that's because that's ultimately the question we're trying to solve. Like, how much of this can I really offload to my AI agent, and how much involved? Because that's the real question, right? If I still have to do as much work to write my blog post, why am I going to use AI? Right?
I like that. Actually, because you could actually then say if my grand thesis is correct, right, that its ultimate goal is to help save us time, then maybe there's some element, like you said, that's, I would say, either observable, maybe not as easy to say, hey, I saved you 10 hours today of writing time or something, but measurable, objective, and like, can you actually save me time? Although I'm interested, I'll just lob this out, see what you think. Like, do you think this era, and I think this is a data center point too, right? Because you could argue that you need a quantifiable way to measure gains in these technologies. Like, remember in the 2000s, it was always about megahertz then gigahertz. Like it was every time you had a new, it got faster, and you knew it would open Word faster, or it would do things. And I wonder if, I hate to say something like that would come back, but I'm curious if there's something that just says, okay, this one's coming, and it's blah 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 blah, which means we can tell it's going to be faster at all these tasks you're used to today.
I know, like just last week, somebody pitched me on a coding support AI tool, and their tagline was make every coder a 10x coder. Right? There's this myth in programming circles of the 10x coder, who's just naturally 10 times faster than 10 times more productive than every other coder in the team. Right? And I think that's sort of, I think that's how some of the big companies like Facebook is pretty good at tracking the productivity of their programmers. I'm willing to bet that they're already studying this in a pretty fine-grained way, is coders who use this much AI support, Copilot or what have you, to do their code, is it really making them faster? Is it making them better programmers? Because Facebook is large enough and good enough at this that they can measure this pretty well and they can quantify it. I don't know what the rest of the world uses. I do think you're right. We're going to see we're going to go back to people talking about clock cycles, but we'll replace the
Yeah.
numbers with flops and tops.
But to your point, that's such an ambiguous number. Like, I don't think that's helpful. And if all tops aren't equal, so what, right? It's
I mean, I think there's this sort of broader question we've had for years now is how much more productive does software in general, not just AI, but
mm-hmm.
all software, does it make us more productive?
Mm.
And yes, it certainly you can write things faster. You can do lots of things. You can do spreadsheets faster. You can code faster. But it also comes with cost. Like you got to spend more time installing software and getting it configured. And so, is the world better because of software? Is it more productive at least? Yeah, probably. But not magical
Yeah.
100 times, 1,000 times
Yeah.
software. And I think the
I
same
know
is going to
this
be true of AI.
and I know this is a just back to this tops point. This was prior to this generative AI moment, but the last couple of years Apple used to very specifically say the number of tops that they have on device. And as of last fall, that just became a number that got flashed on the overall summary chart. They didn't even
Right.
say it anymore. They still say
Right.
billions of transistors, so they still like that number. They probably won't forever. But tops is no longer talked about. Maybe they will again, but I just thought it was interesting that it's not a number that they say verbally anymore. It just shows up as a point on the screen. So even to them, arguably not maybe not the best metric.
I mean that also goes to what are we going to do with AI? Because we've mostly been talking about helping humans do productivity tasks, but lots of people are going to use them for other things, right? And Apple's the prime example of that. Apple has already a significant amount of AI silicon on their chips.
Yeah.
It's mostly doing image and video processing,
Mm-hmm.
right? And how do you measure that? I mean, remember a few years ago when there was this megapixel race to have the most
Yeah.
megapixels in your camera? We very quickly hit the limits of that, right? Because there are other things that matter for image quality beyond megapixels.
Right.
We're probably going to go through something very similar with AI assist camera
Yeah.
stuff.
Right.
Um, but
Yep.
how do you think about it? How does Apple even think about that? Like what's like how do you define the problem, let alone measure it? And I think that
Yeah.
and AI is going to be used for lots of different things, and so we're going to have lots of different ways to quantify that.
Sure. I think the most important takeaway for me from all of this and the discussions we've had is exactly that point you made about the megapixel race, which was also the megahertz to gigahertz race, which is also the bit rate, kbb to gigabit. At some point in time, it doesn't matter anymore. Like we're in it right now. We feel that pain. We see, oh, it's slow or it's not good. But 5 years from now, it'll be an object like you won't even know, right? We'll be past that
Right.
curve, and just
Right.
because something gives you 10,000 words faster, like it's so fast already, it's just on it. But we're in that interesting cycle, which is why I think it's fun to observe and talk about for the next few years because we are going to see distinct issues or challenges on some of those on device experiences, but everybody's racing to fix them. So it's a fun problem, but also you're right, one that we're only in for I don't know a few years, maybe a little bit longer, but it'll get solved.
Yeah. That's right. We're going to be hearing a lot about tops for the next few years, for better for worse.
Yes. Well, I'm excited. I'm excited for it. All right, so that's our preamble on device AI. Hopefully, everybody thought that was interesting. Chime in with thoughts if you have other comments or critiques on how we view it. I always like the responses we get on Twitter. But until then, like I said, we got an exciting episode next week. So look forward to that. But we will talk to you all then.
Yep. Thank you, everybody. Thanks for listening. And please click like, subscribe, share with your friends, all the socials,
Give us a review on
and
iTunes
give us a
if you're a
review on
friend.
iTunes.
There you go. Thanks a lot. All right.
Thank you.